In this video, we're going to take a look at an initial value problem that deals with velocity and acceleration and position. So let's jump right into it. If I throw a ball straight up in the air with an initial velocity of 60 feet per second, what is the maximum height that the ball will reach? Now, as we look at these, we're going to assume that we're on Earth, but we're going to neglect air resistance. We're going to, All right, so here we know that acceleration due to gravity is equal to, so this is in feet per second, so we will use the feet per second. So it's negative 32. And that's a constant acceleration. If we were to integrate that, remember acceleration is the derivative of velocity. So the integral of acceleration, if we were to integrate acceleration, it should be equal to velocity. And so we're integrating negative 32 with respect to time, so I'm using t as our variable. This will integrate to negative 32t plus some constant c1. What do we know about the initial velocity? Well, we know the initial velocity is 60, so our velocity at time 0 is 60. And so negative 32 times 0 plus c1 is 60. So c1 is equal to 60. And our velocity is negative 32t plus 60. Excellent. Now what? Now we want to find its height. Its position, a function that describes its position. Remember, the position, the derivative of the position is the velocity. So if we were to integrate the velocity, we should get the position. So here we're going to add 1 to our power. So t to the first will become t squared. Divide by the new power. Negative 32 divided by 2 is negative 16. 60 integrates to 60t. And don't forget, plus some constant. Let's call that c2. All right. Great. Now what? So now we need to know what is our initial height. And so if we're going to go with an initial height, let's assume, so the problem didn't tell us, but let's assume that we have a person that is 5'10", right? So if we know that the height at time 0 is 5'10", that is approximately 5.833 feet. That is our initial height. And so we can use that to say negative 16 times 0 squared plus 60 times 0 plus c2 is 5.833. So c2 is 5.833. And we have found that our position function is negative 16t squared plus 60t plus 5.833 3, 3. Great. So that's not too bad. Oh, except for we're not done because we were asked to find the maximum height. So this describes the height at any point in time. How do you find the maximum? Okay, so to find the maximum, we need to take a derivative. So s of t was negative 16t squared plus 60t plus 5.833. If we were to take the derivative, we're getting back to the velocity, negative 32t plus 60. Set that derivative equal to 0, find those critical numbers. So t is 60 over 32, which is 1.875. So our maximum height is going to occur after 1.875 seconds. How do we find out what is that actual height? Well, we're going to plug it into our velocity. So our position function. S at 1.875 Now, if I didn't know about the setting, then I would need to verify that this is going to be a maximum and not a minimum. But this will make sense, right? We've thrown it into the air, so it should be going up. It will hit a maximum height, and then it's going to start going down. It's not going to go up and then keep going up. And it's not going down and then going to start going up. So this is a maximum. And when we plug that in, we get a maximum height of something like 62.083 feet. And that's how you can use integrals to find solutions to problems related to physics. All right, come back for our next video and we will look at some more applications of antiderivatives and integrals. In particular, how do they relate to areas? So we will see you there.